We are going to talk about container security, but first, at a show of hands, how many people have administered a production cluster ever? Oh, quite a few. Let's see your scars. How many people in the room write code that gets run as containers in production? That's a good share. So this talk is for all of you. Well, cluster admin, you have just provisioned a most secure cluster in the world. You're probably using OpenShift, which is secure by default. And you are so advanced that you probably went ahead and provisioned some pod security standards as well. So you've looked at your workloads and you actually kind of understand what's going on. But the question becomes, how do you help your team maintain container security? Because you know what they're going to do. They're going to do everything they can to break it, right? So what we're going to review is, and the answer actually is, I'm in delay of one slide, aren't I? This was that slide, process. And the answer is process. Now, I'm going to go through a lot of detail, and I apologize. Some of these slides are eye charts. Don't worry about them. There's going to be a takeaway out of each slide. It's really focused on process, what you two can do together, but it is very technical, honestly. So there's going to be a lot of detail here for you to just use afterwards. So try not to get distracted by the level of detail there. So we're going to talk about what do you do during build or code/build phase, what do you do when you deploy, and what do you do in runtime. So starting off, I'll try to talk about what the risk is and then how do you mitigate it. The first thing that I need to make this a little larger. There we go. So the first thing that most users, our customers do is they worry about vulnerabilities. It's still, even though there's a lot of debate in the industry, it's still considered the first thing you want to do is get rid of known vulnerabilities. So the first thing that you should do in your environment is integrate an image scanner. Some do it in code, but if you're using something like Stackrox or Red Hat ACS, that's built into the system. Get into the habit of scanning base images and get into the habit of maintaining those approved images that you've scanned for base images. But also, and this is process, you need to establish a process for regular scanning of your approved registries or the images that come into those registries. And you need to think about what are you going to do with that. We'll talk more about that, but the essence is we're already talking, right? You need to report back to the developers because how do you fix a vulnerability in your process, in your image? Anyone? How do you fix a vulnerability in your image? You replace it. That's the only thing you can do. You have to replace it. You have to rebuild the image. And so there's already process there. Next, you've already integrated the scanner, but now we're into what do you do during the build itself and why. So there are a couple of different areas that you want to consider, like why an image may be unsafe for you. And there are two, like supply chain examples and actually image examples. Now, from a supply chain perspective, you may only approve in your organization which registries you allow your users to use. That's what you should be doing. What if the image is not signed? So go back. You need to think about this. You need to think about how you're going to sign your images during the build, but you also want to verify them. And there are a lot of bad things that can go into images. So for example, and we'll talk more about this, what's called living off the land. Has anyone heard about living off the land? Living off the land means that attackers, whereas in the, let's say, VM days, you'd have viruses and antiviruses and long living, and they'd penetrate and rely on you to make a mistake. Living off the land means that attackers just use whatever they have. So if they can use an API, if they can use wget, if they can use CRL, they're going to use it. Why would you have a package manager in a pod? You shouldn't. So what you should do at that level, this is your, assess image policies during your build, which means first you have to establish those security policies. So security folks, it's up to you to establish those security policies. Now you want to integrate them into the pipeline. So something like Stackrox command line, you integrate it into the pipeline and you can selectively fail the build. So the key takeaway from this stage is, after you've established your security policies, is don't hesitate to fail the build when you need to, because that's the only way to force correction back into the process. Next, we're still in the build process, but now let's talk about workloads. And so in my intro, if you read the intro of the talk, I promised to talk about the two different types of policies in Stackrox, but given time, I'm going to limit it. But there are image policies and there are workload policies. But the fun part is you get to check both of them in the build stage. So what are workload policies and why would you use them in the build stage? Is because now your threat is that your workloads don't meet your security policies. And there's so much that you can do wrong with a container. But it's also that the image associated with that workload doesn't meet the security policies that we just talked about. So you have to think about both. You have independent scanning of images, but when a workload comes and says, hey, I'm going to use this image, you want to make sure that image has passed your approval. There's a ton of examples of bad things that you could do in workloads. Actually, Kubernetes is insecure by default. OpenShift is secure by default, but there's still a lot a lot left for users to go wrong. So you really need at this stage to establish your workload security policies. Go look at best practices. Compare with a pod security admission that has been introduced in, what, a couple years ago now? And that's a good start, but that only kicks in upon admission. It says, I have 3 classes of securities. I'm going to let you do A, B, or C. Here, you have more flexibility and more control, and but you are forcing developers to do the right thing. So you're actually going to tell developers, no, you need to change your YAML so that you drop all capabilities. The other thing is, and I hope that you're doing this, but in your pipeline, we talked about the build pipeline. You're building an image, you're sending it to a registry that it's going to get used later. You should be doing exactly the same thing with your YAMLs. They should be approved and go into a repo later to go into production. So implement that check en route to where you're going to store it. Set up a process to inform your developers about these policy violations. How are they going to fix it? How are you going to let them know? If it's Stackrox, you get a big explanation in text about what you're doing wrong and how to fix it. It's not always enough. And again, selectively fail the task. Now, selectively is important because you don't want to slow your developers too much, but at some point, you're going to need to put your foot down. The next thing you want to do at this time is think about network isolation. Now, this is hard. It is so hard that very few people do it. How many people are familiar with Kubernetes network policies? A handful. And how many have implemented Kubernetes network policies? That's nice. Still those handful, but just a little bit. It is very hard. But if you want to learn more, come talk to me at KubeCon. I'm giving a presentation about how we can help you generate network policies just based on your YAML resources. A fascinating topic. If anyone wants to talk to me later, please do. Whichever way you do it, don't think this problem goes away. You need to isolate your networks. So we're done with the build stage and we're into deploy. So what are we going to do now? is we're going to run the same checks again. Why? Because the risk is still your workloads don't meet your security policy criteria. Maybe it's one of those workloads that you let pass in the pipe. Maybe something changed, a new vulnerability has been discovered. Maybe you've updated your policies since. This is really your last chance to check a workload before you let it in to your production. Use an admission controller, such as, again, with Stackrox or the ACS, to reject violating workloads. And in Stackrox, we also actually have a fallback. We would either use the admission controller that's built into ACS, or we would try to scale the deployment down to 0. This also brings back the point to what do you as a security admin do with those policies? There's a lot of tuning. Think about how you're going to apply those policies to namespaces, to applications. Who are you going to exempt? What are you going to include? What are you going to exclude? If you're new into this and you're starting off into production, take it slow. Choose a cluster to begin with, a namespace to begin with. So there's a lot of thought that you need to put into this process. And the takeaway is establish a violation management process, again, back with your devs. So violations are going to show you all kinds of security violations from the policies that we talked about. They're going to show you vulnerabilities, and they're going to show you security violations. So some of this is going to go back to, I already have vulnerability management. Okay, go fix it. But if you have other violations, like how long do you allow developers to have these violations around? Is it 30 days, 60 days? Why? What severity level? And have that conversation between security and your dev team. Setting up that process, by the way, also involves thinking about a back-end system that's powerful enough, and usually enterprises have back-end systems that are powerful enough. So violation management isn't an afterthought. There's a lot of back-end process into that. Now let's talk about runtime. The security in runtime is, first of all, you've got something running. You already checked it. You checked the image in the build. You checked it in the deploy. Everything's great. But now it's running, and a new CVE was found. What do? So cluster admins, how many of you kill that application right there when the violation is found? Severe, critical violation. Do you kill it? Luckily, nobody said yes. Why? Because that is a way that we call how to automate an outage. If a new CVE is found, you take the application down, it's trying to come back with the exact same violation. So that is a problem that you cannot automate. This is one place where you have to establish a process on how to monitor those new problems and decide what to do with them. And obviously, you're going to have to rebuild. But by the time it takes people to rebuild, you're exposed. It's something to consider. We don't have a magic solution for that. The next one, this is fun. There's a lot of fun in looking at what containers are allowed to do. And we have a saying that containers should be boring. They shouldn't be doing anything out of the ordinary. They shouldn't be doing fun stuff like, if I see a package manager, again, in a container, I should have prevented that long before. I should have not allowed it to do SSH, because there should be no SSH in the container. But as you know, security is just layers upon layers, check and check and check and check it again. So if you see any one of those suspicious activities, and I know the text is too small for you to see, but there's so many interesting things that you can check with containers. The point is that you have now to think about runtime. So thinking about runtime is, what are the type of behavior that I do not want to see processes in my containers doing? And of course, you want to alert. I didn't mention this before, but any type of violation, you need to choose if you're going to only alert or also enforce. Same case here. Except in this case, I would say you can confidently terminate offending pods. Why? Because they're going to be respawned. So this is different than what I just said before. If you take down an application, it won't be allowed back in because it's violating an entry policy upon deployment. In this case, the assumption is that something changed in the container. Somebody penetrated it. It's not doing something that it's supposed to. Kill it, it will be respawned as clean. I think I'm going well in terms of time, faster than I expected, so I can, if anyone has questions during, feel free to interrupt. Taking another spin at this, there are two ways to look at process and network behavior. Like one is you want to inspect, and there are certain rules, the things that you want to prevent. Like I said, you don't want to have SSH. You don't want to have package manager. Also from networking perspective, most organizations say you're not allowed to have SMTP. Why would your container need SMTP? Well, it's what it does. It's an email application. Okay, that's going to be an exception. Nobody else is allowed to use SMTP because that's a way out of your container. So the question becomes, how do you establish what is a good behavior? And that's a hard problem. Stackrox gives a couple of tools for people to establish network behavior and process behavior. On network behavior, there's actually a chart there that's a little bit hard to see, but Stackrox examines what's going on with the network, and after some time, it just says, well, this is normal. And usually it is, and you can refine it. Process is a little bit harder, but that doesn't mean that the problem isn't there or that it's not a good idea to have. So going back to that, pods should be boring, it's the same statement, except one is proactively identify what you don't want, and the second is just behavior-based. If you understand what's a good behavior, anything that deviates from that should be stopped. And there's one particular element that helps attackers in their what is called the kill chain. So what do attackers do? They find some footprint, some leftover credential, some easy, like non-suspecting pod that nobody cares about, and they're able to enter it. But that's their entry point. And from that, they try to escalate. So after they have this initial access, they're going to try to enter another pod. And the way they're going to use it is, one, they're going to use the tools that you give them to. So which means any pod that is out there, it's a research pod, it's a lab pod, that can serve attackers as an entry. So do not underestimate those low-life containers because they can be used to penetrate others. But this particular one is pod exec and forwarding. So these two API calls is what allows usually us as debuggers to go in and into our pod, right? You want to do a pod exec, so from your machine, fine. But nobody else should be doing it, and that absolutely should not happen in production. So these are two just dangerous API calls that Stackrox can block, and the recommendation, the key takeaway again here is absolutely block that in production. Do not allow these two. If you succeed in doing that, I don't know how far people can see it, but right there, you're gonna cut the rope on the kill chain. And we're on the last step. So the last step here that I talk about is looking into some of the sensitive things that people may do that we haven't trapped. And specifically, this is any access to sensitive Kubernetes resource. Meaning, if somebody is modifying a cluster role binding in production, in runtime, which is not going through your GitOps process, where it should have gone through, that's not a good sign. So they may be attackers trying to give themselves permissions. They may be trying to cover up their tracks. There's a whole bunch of sensitive resources like config maps, network policies, security constant constraints that nobody should be messing around with. They shouldn't be looking at them, and they definitely should be writing them. So magic bullet there isn't, because what you can do here, again, with Stackrox and ACS, is you can monitor. And based on your monitoring, you then have to decide what to do. So we're a little bit early in time for questions, and I'm happy to go back into anything that you want more detail on. Go for it.
Yes.
Yeah, you won't hear yourself. It's just for the
Okay.
recording.
Sorry. Yeah, so here, do we assume the attacker is inside the pod, or is he trying to exec from outside the pod?
Question was, do we assume if the attacker is already in the pod or trying to exec? So the case here is that the attacker has penetrated some pod in your cluster, not your pod maybe. You're good. You're a developer following good practice, but they penetrated a lab pod that somebody left behind. That's how they're going to start. This kind of brings in how many people have heard of zero trust? Wow, good. So zero trust architecture, but the concept is exactly like you said, assume breach, assume somebody's in your cluster already, and they're going to try to move over to your pod.
How can they do that?
So how can they do that is, again, so the question is, first, how can they penetrate a pod to begin with?
Let's say they have access to one of the pods. How can they access another pod from inside your current pod?
So that's exactly how you would do that. Is you would use pod exec, and you would then gain permission from your pod to enter another pod. Just like if you do exec from your terminal and you're now running a shell inside your pod, somebody can do that either with kubectl. They don't have to have kubectl. They can write a script that calls the API directly. Say again? With curl, but you're doing a good job. There's no curl on that. Let's say on that lab image, there's no curl either. Even if it's a relatively thin. If they have access, they can write a script, and if they can do pod exec, that's it. They're in your container. Is there a product that can run and?
There are products like Prisma Clouds and Tenables and other things. Do we have any other products which can monitor these kind of traffic which is going out of the pod, or some attackers coming into the system and seeing what kind of bits and bytes are moving out of the pods? Can we do?
So the question is there any way, any product to monitor the traffic coming out of the pod? I think the question is
Overall pod security itself, not just network traffic, but from the pod security itself. Hey, this pod should not have a curl, right? Can I run policies to make sure that it's not doing that across the cluster itself, not on the pod, but on the cluster itself?
So the question is, can we actually apply those policies on the whole cluster instead of like pod by pod? The way to do it is workload by workload. So this is about, what's a cluster? It's just a few nodes. And if you're asking, is there some oversight to look at everything that's happening and prevent that? So there is the pod security admission, which runs pod security standards. This helps in a sense of looking at what pods are allowed or not allowed to do, but just from but from some restricted perspective, because it's looking at things that a deployment should do. It shouldn't run as privileged. If it's running as privileged, it would get bounced. But from the other things that I talked about, like how would you know if there's curl in the image, is exactly follow the steps that I said. Start with the build. Make sure your developers don't put curl in the image. Check it again during deployment. And check it yet again in runtime. If somehow it escaped and somebody's actually running curl, Stackrox will trap that. So if you're wondering, so ACS or Stackrox, Stackrox is our upstream. So Stackrox monitors everything. You don't have to say, hey, I want to start monitoring ABC. All your pods are being monitored. If we see a curl coming out of any process in any pod, the policy will kick in. Go for it.
I was going to say, the basics of least privilege and CTA, you're basically saying, okay, yeah, all right. Yeah, I mean, the basics, you control what your users have access to, and you control what commands they can run, and you also harden, even before we had the cloud, we had the idea of hardening servers, where you basically said, you can't run these commands. These services aren't going to be installed on a server, and you basically carry that over to virtual machines and to containers. So basically, you say you break it down, you harden it, you don't allow users to have certain permissions, and you don't allow the containers to have those different applications or commands available to them. So yeah, you just basically create a kill box, and
Yeah.
you harden it down to the point where it's like, okay, what's the base functionality do we need? And of course, whether it's policies or firewalls or whatever different layers of the onion for security that you create, so that you can have multiple ways to cut it off.
Yeah, absolutely. And so that actually, brings another perspective. So the person, your name? So Mike was saying it's layers of security, but fundamentally you want to harden down your applications just like you do anything else. So here's a question. So developers out here, how many are using really lean base operating systems like Alpine or something else? How many people did not fully grasp the meaning of my question? Don't be shy. So you all understand why you should be doing it, and yet only a handful are doing it. Why? It's hard. Why is it hard?
It's difficult because people are maybe more familiar with other images.
Why is it hard to use a lean image? Well, I don't know. It wasn't so hard for me. I was trying to design. In fact, in some cases, I'm using a from scratch image. I'm building, a completely static binary or whatever, and copying, only exactly what I need. So the only thing that runs in my container is literally which is hard, right? But it means that you need to do different tool chains, different whatever. People may not be familiar. I'm not sure why people think it's hard, but I think that. And it may just be that they've heard it, but they're just familiar with, use Ubuntu or whatever, basically, just something simple that they know already. I don't know why people don't.
Okay, so some people find it hard, even though it's questionable why it is hard. Behind you?
Well, maybe a related thing. I'm running Silverblue. All of my boxes run Fedora Core OS where the hardware will support it. So yes, I do run that stuff. The reason I'm comfortable doing that is because I was working on the OpenShift team and with people who were working on it at Red Hat while those things were being developed. That makes me comfortable. So I write a bunch of blogs about that. But that leads to many of these, you're describing how to create the policy, but the biggest problem with this really is helping the users understand why, the developers, why a minimal container is desirable and is worth the effort. I'm going to go up to the Docker, the container thing in a little bit. I have a container image that runs DHCPD. It's 16 megabytes. It has one binary and the 12 libraries necessary. I have a script that regenerates it from RPMs. But it took me a while to do that. And again, I'm a person who's already comfortable with this.
Right.
I don't know how to get people. How do you convince developers? How do you persuade them? Because enforcing it If you try to force them, they're going to do the easy thing.
That's right.
How do you get people so that the right thing is the easy thing? Because that's the only way that they're going to do it.
That is the key question. So thank you. So how do you get the team, as a team, security and developers, to agree and understand that it is important, that it's important to take that effort, and that it's important to minimize the attack surface on your containers with everything that we've talked about?
Nothing more fun than hearing about a vulnerability, having a VP come in and say, "Oh, have you patched it?" I'll get right on it, and they walk out and you go, "It's not on our machine. We don't have that broken thing.
That's right.
We're safe." That
Yeah.
is a great feeling.
Yeah. So again, just to repeat, a great feeling is if the VP comes in and says, "There's a dangerous vulnerability out there. What are you doing about it?" It says, "We already took it out. It's not running on our machine."
I think one of the big things is that the thought process for living on off the land attacks is so alien to the thought process for developing and running applications that it's hard to get into that, headspace. And the reason that things like curl and wget are not desirous to not have in containers, people don't think of the kinds of network attacks that you can do with a bare Python interpreter or a bare Perl interpreter. But those things do have the capabilities to reach out through sockets. And if you can write to a socket, you can make an HTTP API call. And if you can make an HTTP API call, then you can call against the Kubernetes API or any other API that's there. And, like as you kind of walk through what you can do, people don't think, "Oh yeah, I'm going to use Perl to attack the Kubernetes API," but it's absolutely possible, and people do.
Right. So thank you for that reminder. Now, there's a whole topic, many blogs, many videos that show you how attackers use those tools to do that. Now, if you're going to educate your team, that might be a good path to take. I'm going to take a last question back over in the back.
One thing I think that would help developers like actually use minimum images and all these things is actually having like a company or a source of good supply chain that actually should be handling that and not be the developer himself building a from scratch image and then having to maintain that along with the application that they're trying to deploy as well. So I think it's automating those build systems. Oh.
No, it's fine. You're
yeah.
good.
Like automating that build system, then the maintenance, and having like someone you can trust actually be doing that build for you, and you being able to be like, okay, if I want to develop a Python application, I have a golden Python minimum image that I know will always work, and if something doesn't, there's a vulnerability or something, that company will go and handle it, and kind of like help you remove that load from you, and you can focus on your actual business core, development stuff.
So the question is a desire for somebody else to solve this problem by way of making sure that there's a secure supply chain that we're going to lean on. There are efforts like that, but any large enterprise that I talk to have that process inside of their organization. So supply chain is critical. And if you're working for some of these companies, as a developer, you're going to be restricted. You're not going to be able to use any Python module that you like. You're going to have to use the one from the registry that's been approved, that's been scanned, that has been signed, that goes through all those checks. Mm-hmm. That's why this is a process. And if I'll just wrap up and kind of go through the 10 steps that we just talked about. Maybe I'll take a step here. I don't know if the camera can catch me. So starting from the build phase, you want to make sure you're integrating the image scanner into your pipeline, and that you're doing both assessing images actively as well as assessing their policies. So process, think about, you need a policy to secure images. You need a policy to secure workloads, and you want to assess them. Don't forget to develop Kubernetes network policies. It's a big problem, big topic. Don't give up. And deploy, use the same system to reject some of those dangerous violators. And think about your runtime security. What do you do when new CVEs are discovered? How do you prevent unsafe process, container, whether it's behavior, whether it's specific process that you've identified? How do you cut the attack chain? And how do you monitor access to sensitive resources? Our time is over. Thank you very much.